All right, welcome to tonight's video. We'll finish up Unit 2, Part 1, just answering some questions. First one is limit as n approaches infinity of x squared minus 1. Well, remember, it's n approaches infinity, not x, so x squared minus 1 is treated like a constant, meaning it's not going to change, so therefore the limit as n approaches infinity of x squared minus 1 is x squared minus 1. Because it's a constant. If r is in the real numbers and n approaches infinity, r to the n is, well, it's infinite if r is greater than 1. It's 0 if r is equal to, it's 0 if the absolute value of r is less than 1, meaning if it's a negative, like a negative number in there, it's 1 if r is equal to 1, and it does not exist if r is less than or equal to negative 1. Because if r is a negative number, then it's going to oscillate back and forth. All right, so part 8, or number 8, says find 3 explicit formulas. The sequence is converged to 0. Remember, fractions that are like 1 over n converge to 0. So for example, a sub n equals 5 over n squared. That would converge to 0. b sub n equals 5 over n to the 4th. Or c sub n equals 5 over n to the 7th. All 3 of those converge to 0. If you take the limit of those, it would be 0. There are other examples, but those are just 3 that I thought of off the top of my head. Find 2 divergent sequences. Well, such that the limit of a, as n goes to infinity, of a sub n minus b sub n equals 2. So divergent means that it's, if you find the limit of them, it goes towards infinity. But if you took the limit of the difference, it would be 2. So for example, one that I thought of is a sub n is n plus 2, because the limit of n approaching infinity of n plus 2 is infinite. And b sub n equals n, because the limit of n approaches infinity of n is infinite. However, if you took the limit as n approaches infinity of a sub n minus b sub n, that would equal n plus the limit, the limit as n approaches infinity of n plus 2 minus n, which means it would be the limit as n approaches infinity of 2, which is 2. So on their own, they're divergent, but when you subtract them, it would converge to 2. Find the explicit formulas for 3 sequences that converge to 3 halves. So one sequence would just be the constant sequence of 3 halves. Another sequence would be if I had 3n to the 3rd minus 2n squared plus 1 over 2n to the 3rd plus n minus 4. By observing higher powers, you know the limit would be 3 halves. or c sub n equals 3 halves plus 1 over n squared, because this limit here would go to 0. Find two divergent sequences, a sub n and b sub n, such that the limit, when you divide them, is equal to negative 5/7. However, on their own, they'd be infinite. So one of them would be if a sub n was negative 5n squared, and the other one would b sub n equals 7n squared. Individually, if you take the limits, this one would be towards negative infinity, and then this one would be towards positive infinity. However, if you take the limit as n approaches infinity of a sub n divided by b sub n, that's the limit as n approaches infinity of negative 5n squared over 7n squared, and by observing higher powers, highest powers, it's negative 5 over 7. All right, so that concludes our video, and that concludes Unit 2, Part 1. All right, any questions? Feel free to ask in class. Have a good evening.